Hey guys, today we are going to learn about polygon clipping. First, let us know what is clipping. When we have to display a large portion of the picture, then not only scaling and translation is necessary, but even the visible part of the picture should also be identified. This process is not easy. Certain parts of the image are inside, while others are partially inside. The lines or elements which are partially visible will be omitted. So, for deciding the visible and invisible portion, a particular process called clipping is used. Clipping determines each element into the visible and invisible portion. Visible portion will be selected and the invisible portion is discarded. The main advantages of clipping are it will part, extract the part we desire, and it is used for identifying the visible and invisible area in the 3D object. It is used for creating objects using solid modeling. It is used for drawing operations. It is used for operations related to pointing of an object and for deleting, copying, moving part of an object. We have several types of clipping which are point clipping, line clipping, area clipping or polygon clipping, curve clipping, text clipping, and exterior clipping. Today we are going to further see on the polygon clipping proposed by Sutherland Hodgman. In their algorithm, suppose take this is a polygon with three sides, that is a triangle whose vertex coordinates are 100, 150, 200, 250 and 300, 200. So now this is the clipping window. Now we want only this part of the polygon. So first the left edge of the clipping window is removed or clipped, and then we move on to the top edge, then goes with the right edge, and finally with the bottom edge. There are four possible cases for any given edge of a given polygon against current clipping edge. That is, both vertices are inside. So, in this case, only the second vertex is added to the output list. The next case is that first vertex is outside while the second one is inside. So in this case, both the point of intersection of the edge with the clip boundary and the second vertex are added to the output list. Coming to the third case, first vertex is inside while second one is outside. So in this case, only the point of intersection of the edge with the clip boundary is added to the output list. And last case is that both vertices are outside. So no vertices are added to the output list. There are two subproblems in implementing the algorithm, that is, to decide if a point is inside or outside the clipper polygon. And the other problem is to find the point of intersection of an edge with the clipping boundary. So these problems can be rectified by following those four rules which I have mentioned earlier.
Now let's move on to the code. So yeah, so now as it was mentioned earlier, we have two problems in that. So to find whether the first problem, that is to decide if a point is inside or outside the clipper polygon, what you have to do is we have to see, we have a given formula like P is equal to x2 minus x1 into y minus y1 and the whole minus y2 minus y1 into x minus x1. So for the given P, if that P is less than 0, then point is on the right side of the line. If it is on 0 equal to 0, then it's on the line, and greater than 0, then it's on the left side of the line. That is the given, like according to the algorithm and according to some calculations which we have found to decide if a point is inside or outside the clipper polygon. So that is something which we are doing here in this part of the code. So, and the second problem, to find the point of intersection of an edge with a clip boundary. For that we are using these two functions, x intersect and y intersect. Now that is calculated using the formula x1 into y2 minus y1 into x2, the whole into x3 minus x4, and the whole minus x1 minus x2 into x3 y4 minus y3 into x4. That's it. And that's how we find the x and y intersect. Now further, let's move on to the total code. This is the how we are going to rectify the problems which we were facing previously. So the first line, as we know, it's the basic things include iostream.h, graphics.h, and we have kept maximum points as 20 in our case. So we have kept the constant and everything. Now further, let's go on to the main function, and here we can see that we are already giving the points. We can also have a user make the user to input the points, but here we are just giving the points, and then the G driver and the init graph are just like the basic points which are already done. And then here this is the Sutherland clipping algorithm. For that we are using this function. So once the function is called, it will go on to this part, and we go on to first clipping the polygons according to the points which we receive here. So going to the clipping part, let's first see the intersection. So intersection and the y-intercept and x-intercept are direct formula applications, and the clipping part we have the for loop, and then we get the points, that is ix and kx, where ix and kx are the coordinate values form a line in the polygon, that is this I and k. It's already here. Let's go up, I'll show you the I and k. Okay, now we have to first calculate the position of the first point. So that is, we are using this IPOS for calculating the position, and KPOS. So what we had already discussed, that is according to that IPOS and KPOS, that is if both IPOS and KPOS are actually the two vertices. So according to the one which was described earlier, if both the vertices are inside, that is for inside we use the P parameter which is found using the given formula, and if it is less than 0, it means it's inside. So if both are inside, then only the second vertex, we are adding only the second vertex. Now for the second case, if one vertex is outside and other one is in like intersection, and while the other one is inside, then we will be using this one, that is greater than or equal to 0 for outside and less than 0 for inside. Then what we will be doing is, we'll find the point of intersection of the edge with the clip boundary, and after finding that point as well as the second vertex are added to the output list. Now our third thing is, first vertex is inside while second was outside. So that is the opposite of the previous condition. So in this case, we won't add the second vertex. We'll only add the intersection to the output list. If both are outside, then it's like totally outside the clipping area. So we won't add anything. So we are giving this else simply because if you don't give an else, it throws an error. So we just give it simply an else point. So, and then further coming, we'll be running the program, and whatever are the points that are clipped, it will be shown here, and you can further also draw it by using the line function. So this part is for printing the points, the vertex of the clipped polygon. So after hold the clip, now let's run it and see now once it's run, we'll see all these are the clipped parts of the polygon, that is these are the vertices of the polygon after it's been totally clipped. So that's all about this algorithm, and with this we are coming to an end of this video. Hope you all liked it, and we'll try some new thing in the further videos.